Hello everybody, my name is Mark Spevic, and in this video I'll be showing you how to make this more advanced pyro shot of an agent who is on fire walking through some trees and setting them alight as he walks past. We will look at breaking this complex shot down into a couple of simulations for better control. We will then see how to take the data from one simulation to control another, and we will look at Houdini's pyro clusters in order to simultaneously simulate multiple trees on fire, and also how to customize those clusters to make our simulations more efficient. Let's pop over to Houdini. If you open up the supplied scene, you'll find a pyro simulation around the tree, which will become the basis of our tree forest fire, and also an agent node here who's going to be the agent on fire walking through the forest. So we'd like to set up our forest and keep some of the look that we have from the pyro simulation on the tree here. Now I'm going to need to build an entirely new pyro simulation. I want to do this in two parts. I want to simulate the agent first on fire walking through, or on fire, and then we'll simulate the forest catching fire as he does that. Now in professional shows we often break things down into their different elements because it makes the problem easier to solve. Plus as well the agent's walking, and even though we're going to be using sort of the pyro from the tree as the basis of this, we might need to change some settings because he's moving, so it's best to simulate them separately so we can have that level of control. So let's look at how we can achieve this. So the first thing I want to do is kind of save off my pyro settings so I can reuse them, and that's no mean feat because there's quite a lot of different settings. I mean, if I go inside the pyro simulation here and select the pyro solver node, we can see that there's quite a lot of settings that have been customized. So one of the really nice ways about Houdini is the fact that you can save presets on the nodes, and that's one of the ways I like to carry settings through from other scenes, or at least keep setups that I like. So by selecting the Pyro Solver node here, we can click up here on the gear icon, and we can choose Save Preset. If we choose Save Preset, we can put something in like My Flames Pyro. And then we can either choose to save it to the current HIP file or save as permanent defaults. I'm going to save this just to the current HIP file. So let's hit Save Preset. Now if I click on the gear icon, we'll see at the bottom there's my preset. Just to demonstrate that, if I do change some settings here, I can click on the gear icon, load in the preset, and you'll see they will jump back to my original settings. The other node that we changed was the gas disturb node. So I'd like to set a preset up for this as well. So let's click on the gear icon, choose Save Preset, and we'll call this my Disturb Pyro. There we go, Save Preset. So again, if I click on the gear icon, we can see that appears at the bottom. So like I mentioned, I want to set all this up from scratch, so I don't really want these Pyro nodes or these sphere nodes, and I'm just going to turn off the grid for the minute. Just move these nodes out of the way. So what we're going to do is we're going to have our agent walk through a forest of trees. We have the agent. Let's make the forest. For that I've got this scatter node. It's basically just a grid with some scatter points, and I've removed a couple of the points for the simulation. And if we go into the tree network here, we had this original sphere which was creating the temperature. Let's remove that. Our agent's going to set fire to everything. Let's get rid of this node and all of these nodes. I just basically want to keep my tree and the paint sop that we had originally, which was just so we didn't have points all over the tree. It was just at the top parts of it. Now I'm going to actually I want to bring in that scatter nodes which puts the trees out within the scene here. So to do that, I'm going to hit Tab and type Object Merge to bring in an Object Merge node, and this will bring in one network into another. So I'm going to click on the little browser at the top here and click on my scatter network, and we'll just say into this object, so it's bringing it in with its own transforms. If I template that, well, we won't see, well, if we turn it on, we'll see the bunch of points we're going to scatter to. So I'm going to hit Tab and type Copy to Points, and I'm just going to copy my tree to those points. There we go. So we've got a few trees here. If we have a look at the agent, we'll see he wanders between those trees. Excellent. Now if we look in the top view, actually they're all at the same orientation. I just want to twist them round a little bit. So for that we can use an attribute randomize node, because the copy to points nodes uses the normal attribute n to orientate these guys. So let's type n in, and we can randomize them using the normal attribute. So if I just type 0 in x and y here and -1 to 1 in z, we'll see we get a random rotation on each one. Just looking in the top view there. So that just makes that look a little bit nicer as he's walking through our little forest here. The other thing I can see is my trees are a little small, so I'm going to add a transform node and scale them up. This will affect the simulation slightly, but that'll be fine. Let's scale them up something like 2.5. We might need to just multiply up some of the noises because we're working at a slightly different scale. So there you go. He wanders through the trees, and he can set fire to them as he goes. So he's closest to this one at the beginning. Cool, so I'm just going to add a little null at the end here, and let's call this forest out. There we go. In fact, yep. So we'll use this as the starting point of our little network there. So we have our tree set up, and we have our agent animation. Cool. So like I said, I want to keep these as separate simulations in order to get control over this. So let's work with the agent first. I'm just going to hide the tree over there, and we'll deal with the agent. So I'm going to use the shelf tools here. So if we click up at the top here onto the Pyro effects tab, and we click on flames, let's select the agent here and hit enter. So this will set up Houdini's Pyro network around our agent. I'm just going to resize the box by selecting it, hit enter. If I hit space 2, I can pop to the top view here, sort of resize the box a little bit more efficiently around him. And space 3, I can see the side view and just bring that up so it fits him a bit better. Before we do anything in there, let's go back into this agent network. Oh look, let's just tidy up these nodes a little. Let's put the simulation node over there for some reason. And let's bring down the Pyro import here. Let me just copy that name agent. I'm just going to rename these nodes to agents so I know what they're doing, because I'm going to have multiple sims in this scene, and it makes sense to keep things organized. Another way to keep things organized actually is to select all the nodes and then click on this box here to create a network box. Let's call this agent as well. So what I'm going to do is just resize this box, and we can also give it a tint by tapping C. Let's give it a darkish color. There we go. So I can tell that these nodes are creating the agent there. Let's dive inside the agent network and see what we've got. It was brought in using this alembic, and then I created a trail stop here to calculate the velocity. We then have a time shift node. This time shift node is just a pausing for 10 frames to allow the simulation to build up. And then I created a paint stop here where I painted an attribute called density. And then the scatter stop is picking up that density attribute and just putting the points where I've painted. This is because I didn't want him to be entirely in flames, just parts of his body. So let's set up the Pyro sim for that. I'm just going to plug that scatter directly into the create fuel node, and let's turn that on. And we'll see it's not working because we've got surface scatter turned on. Let's choose keep input, which keeps our points. And I'm going to drop the particle separation here to something like 0.015, which will just give us a bit of better fidelity further down. If I turn on add noise here, let's create some deeper noise, so -2.5 for the minimum to make it more contrasty. Let's drop the pulse duration to 0.15 and the element size to 0.15. Now if I turn on the rasterize, you'll see that creates the noise with the element size small, and if I press play you'll see the noise changes a lot frame by frame, which was the pulse duration there. So this is the speed it changes frame by frame, and this is the size of the noise that we see. And that's kind of nice for an evolving noise on our agent. It's a nice seat for our Pyro sim. And we're also carrying through the velocities because we're calculating those with this trail stop. Now we're actually rendering this render node, so I'm going to plug in the time shift to that and just display this properly. So I'm going to render the agent with motion blur and not this volume that he was creating. So if I pop over to the simulation now, to the simulation network, what I'm going to do is load in those presets straight away that we saved off. So I'm going to select my Pyro solver node here, go up to the gear icon, and I can choose my flames Pyro. Ooh, let me change that to my flames Pyro. We'll see all the settings change as they were for the tree there. This probably won't work for the agent because he's moving, and another reason for me wanting to do it separately. So the other thing we had was a merge node, and let's plug that into the velocity update. And then we had gas disturbance nodes plugged into this. So let's do gas disturbance. Let's plug that in, and I'm going to run my preset on this. There it is, my disturb Pyro. I had 3 of these at different scales of noise, so I'm holding Alt, I'm just going to left drag, and we'll have one at 0.02, and let's left drag again, and this one at 0.1. So we've got those 3 ranges of scale that we had before. And you can see it was quite simple by just using the presets and drag and drop. I can set this up pretty much to how the tree simulation was beginning before. So if I just press play, oh, it's a little bit low resolution. Let's just go to the object node here and drop this down to something like 0.04 for speed, and then let's see what we got. So this should be similar to the tree. He'll burst into flame. Well, he'll already be in flames for us, and as he wanders off, it's not quite got the look that I want. Actually, I wanted to see the flames sort of shooting up more, but then he is walking through space, not static like a tree. And one of the reasons for wanting to do this separately. Now if I do it side on, we can see there's a bit of an issue here. The smoke seems to be hanging around a bit. It's quite tricky to see, so what I'm going to do is select the volume source node and just increase the amount of fuel to let's say about 3. That way we'll see what's going on a bit clearer. So let me press play again. There's our 10 frames we're using the time shift to pause him for before he moves, and there he goes again, and we can see kind of flames being left behind here. So what's going on? Well, this is where the visualizers can help to see what's happening. So I'm going to select the smoke object node and turn on the fuel visualizer. What I can see is when he's static, that's fine, but as soon as he starts moving, which our tree wasn't, we can see that the fuel's being left behind here and just burning in space, which is not the effect I want. What I'd like to do is see that fuel getting moved with his motion and also burning a lot faster. So there's a couple of things I need to do. Now one thing we didn't do with the tree was in the Pyro solver node here, was to go to the combustion tab, fuel, and turn on advect fuel. Advect fuel means that we're going to stir up the fuel here with the velocity field. Now considering the Pyro is affecting the velocity field, and also his own motion is affecting the velocity field, so hopefully that'll get the fuel to stir up and start moving in a more realistic manner. I'm going to turn on advect fuel and set this to 0.5, so it's like 50% mixing in. So let's press play now, and we can see the fuel's already starting to get a bit fluffy with the flames, and it's getting carried up with the velocity fields that the flames are created, and creating flames itself. Now that's a bit too fluffy for what we want. Let's just turn the visualizer off for a sec. It's not too bad, it's not hanging around, but it's a bit too sort of not quite what I was after. That's also because the fuel's not burning very fast, it's hanging in the air and burning as it gets carried up. I want it to burn a lot quicker. And this is suitable because he's walking, and for this guy, but not necessarily for the tree. So I want it to burn a lot faster, so I'm going to go to the combustion tab on the solver node, because I don't want any of this fuel hanging around afterwards. So I'm going to increase the burn rate up a lot to 0.99, which means it's going to burn a lot more faster, so that'll produce a lot more energy. Also the fuel inefficiency here, this is leaving behind some fuel every time step. If I set this to 0, it won't leave any fuel. All that fuel's just going to disappear. So if I press play now, we'll see that not only are we burning up all the fuel a lot quicker, but also it's burning a lot brighter and a lot hotter. And we're producing a lot more temperature and a lot more expansion, a lot more gas and pressure from this. You can see it's a lot more energetic. It's good to think about these things in terms of energy. You see that's very kind of fast and frenetic. If we look at the fuel visualizer now though, where's fuel? There it is. We'll see there's, let me turn off the multi-field even, you'll see the fuel gets carried up and just burnt off almost immediately there. We're not having it being hung around in space, which is what we saw before. Now that might be a little bit too crazy, so what I might do is come back to the combustion. Let's bring down the temperature a bit. Let's maybe try 0.3, and then maybe bring down a little bit less gas off him. Let's see how that looks. So you'll see it's expanding a lot less, not getting so hot, and still rising up, but not as crazy as we were seeing before. We've tamed it down a bit with the gas and the temperature there. I see all that sparkling, so the disturbance looks a little bit too much. Let's bring down some of the disturbance. I'm going to select all 3 nodes and bring down the disturbance to about 0.6. You can select them all, and if there's a common setting, it'll update all of them at the same time, which is pretty handy. That looks a little bit better to me. It's not hanging around in space there behind him, and we're seeing these licks sort of coming off. The one thing to do just to make sure I like this is to actually just flipbook it. So I'm going to select the Pyro node. Let's drop the resolution down something a lot higher, and I'll flipbook this just to make sure I like it. So I'm going to click on the flipbook icon there. I'll pause the video while the flipbook happens. Alright, the flipbook is complete. I'm kind of happy with that. I could come back and sculpt the look a bit further, but I'm going to sort of. Yep, I'm happy with that. Otherwise, I'd be here all day. I never know when I'm happy. So what I'm going to do is basically cache that out so we can reuse it for the other simulation. So once you're satisfied with your results, you want to pop forwards and sort of bake them out, and then you can start for the next bit. So I'm going to go into the Pyro import agent node here and select on my Pyro import fields, and I'm going to save out the fields from SOPs rather than from the simulation, because it's less data on disk, and I'm happy with what I got. Now before I do that, I'm just going to turn on this compute min and maximum values. This will help me work out sort of the ranges within the fields that we're going to save. And I don't need all of these fields. I don't need the rest ones for the shading, and I don't need fuel or color. I just really want density, velocity, temperature and heat, so we can see sort of the smoke and the flames that we wanted before. Okay, and I'm just going to pop up here and save out the cache. So we'll call this agent cache. There we go. And I'm going to save the scene, and I'm going to save out the cache to disk in background. So I'll just pause the video while that happens. Actually, before I do that, I was humming and hawing a little bit. I might just come in and select the fuel node here, because I noticed on the agent some of the flames are a bit shooting up a bit fast at funny angles. I might just scale down the velocity on the agent when he comes in. Let's just have a quick flick through for that to see how that looks, because when he started moving his arms, flames are shooting off at quite fast angles. Didn't really like that effect too much. So by scaling down his input velocity here, that should affect that a little bit and not have it go off so crazy. Yep, that looks a little bit better. So I'll live with that. Let's go for that. So I'm just going to drop the resolution back to 0.15, and I will write out this cache again. So back into the Pyro agent node. Let's hit save to disk in background. So let's just pause the video while that does happen. That's now cached. So I'm going to load in the cache from disk here, and I'm going to display the Pyro import fields only, so to not simulate the other network. And then we have our simulation baked in there. If I just add a volume visualization node, we can just see what's going on quickly. So in here we just want to run in our density field for the density, and the same for the coloring of that. We can increase the density a little bit if we want, so we see that a bit clearer. And then the emission here, let's put that up to a high value. So we want to see the heat field in here, because that's the brightness. And the color is driven by the temperature field, and we want to set this to black body to give us an idea. Then we can kind of work out the ranges that we need if we just turn these ranges on for a sec. So our temperature, so again, these shading settings may be different from our tree, so which is again why we want these to be separate. That kind of looks interesting. Oh, 0 there, 2.5, something like that, a little bit more clippy. Something like that is a good preview, so get a nice, give us an idea of what little dude's doing. So interestingly, I have this 10 frame offset, which I don't want actually. I want it to start on frame 1, so I'm actually going to add a time shift here and time shift it back again. So here's our frame number. If I click on the word frame, we can see $FF here, so let's do -10. So taking frames off there, let's just clamp to first. So that should be the first frame. Oh no, sorry, $F plus 10 is what I need here. So frame 1 now become frame 11, and he should start moving, but our agent's not moving because I need to also reset the agent here. Let's turn this on before the time shift so we see the agent on the original there. So this is minusing 10 frames, and then back in the cache we're plussing the 10 frames. So now our sim is working with our agent, and we've kind of got a 10 frame lead in there, which is fine. Could have done a bit more, but that's okay. So there we go, we've got our agent set up and ready to go. So what I want to do now is have this agent start to affect my trees. So let's turn on the trees. Now what I want to do is set up this tree network first of all. Let me just hide the agent for now. So with the trees, we're going to use Houdini's clusters. If I was to set up just a straightforward flame sim for these guys, we'd get one container around all the trees, and I'd probably need quite a high resolution container to resolve them all. Whereas clusters are much more efficient. We've got basically a container for each tree, and they're a great way for breaking down quite big or expensive simulations. So let's have a look at the clusters. I'm going to make sure nothing is selected, click on cluster, choose my trees and hit enter. So when Houdini's made the network, let's have a look what happens. It makes a few nodes for us. Again, it's a little untidy. So let's pop over here, just tidy things up. So we have our scatter, then our tree geometry, and then we have this node, this the tree source points. I'll show you what that does in a sec. Then we have our simulation, and then we have our import bringing back from the simulation. So again, I'm just going to copy this name tree and just put that after the sim, because I like to label things. Oh, tree. I like to label things nicely, and the same after the Pyro import here. Let's also label that tree. Excellent. So there we go. So I'm going to select these guys, create another netbox for them. We'll call this tree, and give that a different darkish color. Ooh, select the netbox. Give it a nice color there. There we go. So our tree network and our agent network. So instantly what you can see if I go inside the simulation network is we have one object, but we have multiple containers, which is kind of cool, which makes it much more efficient. We're breaking down the simulation, and each container can have its own resolution. And if I press play, you'll see it's quite slow, and all the trees are on fire at once. So what I'm going to do is I want my agent to come in, so I don't want any of the trees to be on fire at first, and then as he comes in he sets them alight. So let's have a look at how these are set up, and as you can see we have lots of containers here, more than the 4 trees that we have. That's not helping. So I'm going to go inside the tree source points network here, and let's see what nodes we have. We have this little render node, we have the out bottom of the network here. Let's branch this off. So at the top here we start off with our trees. Let me turn off the ghosting. So this brings in the tree geometry. We then scatter points on the tree, and again we were overriding this ourselves, so we'll do that soon. And then we have this cluster points node. So this node is doing the business here. This is what's it's doing a couple of things. First of all, it's creating cluster points. If I set this to cluster points, that's what we're seeing. So these are kind of the scatter points on the trees, and also they're clustered by different colors. So there's 2 clusters on this tree, 3 on this tree. If we go to average points, it's just going to give us a point at the average of each of those clusters. And let me turn on the point display, and you'll see there's quite a few points. There's more than the 4 trees that we have. And we can set the mode to both. We're actually outputting both for these other bits of the pipeline. So the first thing I want to do is make sure we have a cluster for each tree here. So how can I do that? Well, let me go back up to where we were scattering with the tree. Before I do that, let me explain. So in the cluster points node, we're using this position attribute to work out which points should be in each cluster. And it's doing it by proximity, and as you can see it's actually trying to make 10 clusters. If I say make 4 clusters, that works out quite well, because it's making 4 clusters, and using the position attribute is able to define which tree is which. Often this doesn't work if you have more than 1 tree, but in this case this is working. There's a slightly better way to do this rather than using position, is to actually give each one of our objects an ID. So I'm just going to do that for robustness. So if we come back to the scatter here we're bringing in our scatter points. And what I'd like to do is just create an attribute. So I'm going to hit tab and type wrangle and create a point wrangle. And we're just going to create an ID attribute. So I at ID equals at PT num. So the ID is basically just the point number of each point here. If we go to the spreadsheet, we can see that the ID just matches the point number. And that's the attribute I'm going to use for my trees. Let me just display the forest again. So in the source points node on the cluster here, so if I pop ID in, you'll see again it gives us the same result. But if I put sort of 20 clusters in, we'll still only get 4 because it knows that there's only there's only 4 different unique IDs for all these points. So if sometimes you find that your clusters aren't working based on P, create an ID attribute or some unique attribute for those groups of points, and this will be a great way to cluster those up for you automatically. So there we go, we have our 4 clusters, and if I look at these keep cluster points, you'll see we have our 4 points for our centers there. If I look in the simulation network now, you'll see we only have 4 containers, not those multiple containers that we had before. And you'll see things obviously go a little quicker. This is a bit more efficient. Now while we're at it, I just want to set up what's going on in here with those presets again. Oh, before I do that actually, let's pass through our trees without all the geometry on there. So before we scaled this up, then we can paint on it, and then we'll plug in our new scatter points. So if I just plug these guys in, you'll see instead of geometry I'm actually passing points through. That's not what I want to render actually. I do actually want to render the geometry, so I'm just going to make a copy of this and plug that in before I scatter the points. Let's make a null, and this will be called disp render, because it's actually this is what I want to display and render, although I want to pass the forest out to dops. So we'll call this out out to emitters. Okay, because that's going to the emitters now. And this is actually what I want to display, the real geometry. Okay, and that's the emitters. Cool. So let's go into the tree source point. So this is where I'm bringing in those emitters. So let's now select that to out emitters, and that's bringing in our points. We don't need to scatter now, so I can disable that. We're still going to make the clusters from those, and the ID in attributes inherited, so the clusters are still working. This is going to delete those single points but keep the clusters, and this guy here is set to keep input, so we're going to keep those trees. Let's bring this resolution down to about 0.03. Then we're going to add our noise like before, -2.5. These are the settings on the tree that we had before, 0.15, 0.15. And here we are looping through. So what this does is it creates the points of the attributes. If we just middle click on the information there, you see we get a bunch of attributes here and a cluster number, and then this loop here loops through each cluster number, and it creates a volume for each one of those clusters. So I middle click here now, you'll see that we have a volume called _0, one called _1, one called _2, one _3, and these are for each of our clusters. You'll notice actually in the rasterize we're rasterizing color and alpha. I don't really need those. In fact I don't even need velocity in this case, the trees aren't moving. I just want density, temperature and fuel. So the less it has to make the better. There we go. So this is creating 4 separate volumes, one for each of those containers. And how does it know where to put the containers? Well, it does it through these clusters. These cluster points are the centers of each of our containers that we see in DOPS. So if we dive in here, each one of these becomes its own network, its own Pyro object, and each of those points is the center of the container. And that's worked out here from the instancing tab. If we look at the instancing tab here, it's taking the path of those points, and that's where it's working out where the center, or it's basically instancing each one of these boxes. Incidentally, these boxes won't affect each other. You know, if there's some velocity from this one, it won't really push the velocity in the next one, but they will sort of share the smoke and stuff. You'll see the smoke going through the boxes, but they don't really affect each other. You know, they should be considered as separate simulations. There we go, that seems to be working quite nicely. Now we can actually customize the size of these boxes. If you hold your cursor over this where it says override container size, you'll see it says there's a scale attribute which you put on the points to adjust the scale of these guys. So let's preview that. I'm going to actually lock the view up here. Look, if I click on the pin, it's going to stay in the network here. And if I jump out and into the source points here, it's these source points that we want to add our attribute to. So again, using a point wrangle, we need to create an attribute called scale. So this would be a vector at scale equals, so we'll call it a channel vector called scale. So if you type this expression, v at scale equals chv, and then brackets, inverted commas, scale, inverted commas, brackets, inverted commas, brackets, this will create a channel for us. And you want to click on this magic icon at the right hand side, which will create that channel for us that we wrote in the expression here. And there we can see the scale at the bottom. Now I can interactively put in numbers, and you can see as I do that, our containers change size. So there we go, let's try 2.7, 2.74. That's something similar to what we had for the original tree. And these are also controlling the positions as well. So if I add a transform node, I can actually offset them in Y as well and bring them up and down on our trees and resize them and reposition them that way. I kind of like that. Let me turn the ghosting on so I can see where the trees are in relation to that. So maybe they want to be a little bit bigger in height, something like 5, maybe even 6 as a starting point. And then in the transform, I can just transform them up a little. Something like that will be good. So there's a good starting point for our trees. And if we press play, the resize will snap down and then resize back up on them. Actually, talking about the resize, let's pop into the, we don't need to see those source points. So in here, select the resize, click on max bound. We don't initialization dynamic, because that's just going to do it on the source points. We actually want to do this from static. So it's going to take that from the original shape that we set in SOPs there. So you go, those guys are popping through quite nicely. Let me pop this off. So what I want to do now is just set up the presets like we did before. I'm actually going to be cheeky. I'm going to dive inside the agent network and select all of these, not that, all of these nodes for the noise, and do Control C. And then dive inside the tree network here, and I'm just going to paste that in. So I can just steal all of those gas disturbance. Now we're talking about a bigger scale here, so some of these smaller noises might not work. So I might just double some of these values, because we're almost double the scale of the tree there. So say 0.2, 0.4, and 0.1. We can always add in smaller ones if we need. I'm going to load in my preset for the solver node here, because that did work for the trees. So let's load in my flames Pyro. And there's the tree set up with our presets. So again, because of the presets and using copy and paste, it's very, very fast to take certain networks and share them between yourselves. So that's looking okay so far. I might want to increase the amount of fuel coming off those trees. Let's have a little look. Is there enough fuel there? There's enough flames coming up. Kind of interesting. Maybe resolution would help. So I'm just going to select the fuel here, and let's just add a little bit more fuel. Something like that. And that just gives us a bit more body in the flame there. Is that going to be rising up a bit? That's good. That's kind of yep, that's kind of the effect I was after. Now they are a bigger scale, but that should look similar once we drop our resolution down, and we can see there's some nice detail on the trees there. Excellent. So what I want to do is get my agent to affect these trees. So let's go back inside our source points here. It's the source points here that we're creating the fuel volumes, and like we did before, let me just move these guys over here. Like we did before with the sphere, I want to separate out the temperature, and I want to add that in using our agent, in fact using the animation that we've already cached out, the simulation we've already cached out. So up here at the create fuel, this is where we're creating the fuel and the temperature. So I'm going to set the default value to 0 and the scale to 0, so there is no temperature created at this point in the attributes, but you'll see we still have temperature. That's because we're adding noise to the empty field and creating some values that weren't there. So I'm actually going to remove temperature from the noise, so there is no noise from the temperature there. It's going to be fairly uniform. And there we can see the flames have gone out. If I press play, all the containers resize to nothing because there's no fuel in there, there's no temperature in there. So let's bring that in from our agent. So how can we do this? Well, there's a couple of ways we can do it. One way is to bring it directly in from the simulation, which is a bit slower, or we could just transfer an attribute in. Let's have a look at both methods. I'm going to hit tab and type object merge to bring in our agent. So the first thing I'm going to do is actually bring in the simulation itself, from the import node. So if I go up here, I can find my Pyro import agent node. Let's open this up, and we'll see the import Pyro fields node. This is what's actually bringing in those Pyro fields. In fact, I better do this after the time shift because we offset everything by 10 frames, didn't we? And you want to specify it into this object so it comes in with its own transforms. Now if I look at this, we'll see our agent there, or all the fields. And I don't really want to bring in all the fields. If I middle click, you'll see there's quite a few of them. So I'm going to click on group here and just bring in, okay, at heat. Oh, sorry, my syntax is wrong. It's at name equals heat. Ooh, for the attribute there. So there you go, at name equals heat. So there you go, it's just bringing in the heat field here. So we can't really transfer attributes from a volume to the points here, but what we could do is scatter some points in that volume. Let's plug that in. I don't really want to scatter because that slows things down. So we have points scattered within our heat field here. What we can, so they're filling up roughly the volume where the heat is in the air around him. We can also capture some of these. If we do an attribute from volume node, so where is it? Attribute volume from volume. That's it. So tab attribute from volume. There we go. Let's plug in the points. We'll plug in our volume from the attribute from volume here, and then we're going to be calling this heat, or let's actually call it temperature. Let's use the temperature. Temperature. There we go. So this will be a one-sided value, and actually up here, instead of bringing in the heat, let's bring in the temperature field instead. There we go, instead of both. Or we could bring in both. But in here, I'm going to now load in the temperature attribute. There we go. So now we've got a bunch of points in here, and they've also got the same values as that field. And just to prove that, if we go to the geometry spreadsheet, you'll see we've got the temperature here mapped out onto the points. We see it's actually maxing out about 8. So this might be a bit high, but we'll see how we go with that. And that'll obviously move through. So this is quite a slow way of doing it. The other way we could do this, because I don't think it matters too much, but it's nice to know that you can actually bring in the real values if you want. We'll call this object merge agent fields. The other way is just to bring in the agent geometry itself. So let me just make a copy of that. So agent geo, and I'll just load in the agent geometry himself. So again, we wanted to do this before the time shift, so that was the trail SOP. Let's turn that off. And on this guy here, we could just create a our own temperature attribute and just transfer from that as well. So we could say f at temperature equals 1. So this might be slightly more controllable because we've got the right numbers, although we could remap these. So it's up to us which method we use. It doesn't really matter. What I'm actually going to do is, if you remember, before the noise or even after the add noise, they're points at this point. I just want to transfer the attribute of temperature into this temperature on these points, because remember this was set at 0, and if it's not 0 these will burst into flames. So we can transfer that temperature attribute from either of these methods. I'm probably going to use just the geometry actually, because it might give me a slightly more control. So I'm going to create an attribute transfer, and then where's the add points? There we go. Let's just plug that in. Where it says points here, let's turn this on to temperature. We're not doing any primitive attributes, and we have the distance threshold, but we don't know how that might be working. So in order to see how this is working, I'm going to use a visualizer. Let me just template my agent. Let me turn off any ghosting, and I'm going to use a visualizer. So hit tab and type visualize, and I'm going to leave it on color, but I'm going to use temperature so we can see the attribute that we're transferring in. Oh, there we go. Mustn't get a typo. Now if I increase the distance threshold here, we can see that that is in fact transferring in and displaying as a red color. So let me move him forwards and think, well actually when he gets about here that might be hot enough, so let's just increase that a little bit. So, or in fact actually he should be so close he's setting fire to it on the first frame there. There we go. So he's just close enough that he's burning that on the first frame, and as he goes in you see a few frames later that next tree will start to burn, and as he gets close to it he transfers his heat onto these rather dry trees and they'll burn. So I just want to make sure some are on the first frame there. So that's working nicely. We're adding this heat attribute, or this temperature attribute, and we're creating values into that field. So that should be it. If I just plug that in, we're now feeding that temperature into these fields. So let's go into the simulation network. Let's turn on the ghosting. Where's my little agent gone? Let's turn on the agent sim so we can see him. There we go, back into there. So let's press play and we'll see. So the first container has some fuel happening in it, and as you can see that's starting to burn, and as he's going, not just as the flame's spreading, but also he's also increasing the heat on that tree, which is burning it across as he walks past, and we see the flames spreading. But as he's walking to the next tree, that doesn't catch fire. There's a slight issue here, as you can see, is when we got the resize on, because there was no flames or density happening in the first few frames, these just snap down to 0. We can actually fix that. We could actually say on the resize here, use fuel as well as density, but this is not the best approach because it now won't resize around the fuel, as you can see. But it is an approach, but it stops the boxes resizing because the fuel's over the whole tree, but which is good. And as he transfers attribute in, we'll see the next one fires off. I mean, this could work, but again it's very inefficient. We're simulating a lot of empty boxes for a lot of time, and that's not the best way of doing it. So I'm actually going to not use the fuel here, and I'm going to use another slight method that we can use with clusters, a little trick. If we select the Pyro object here with the instancing, we can turn on this continuous method. What that means is we can control when these boxes appear and disappear by using the points that created them. Let me show you what I mean in another example. In this scene I have 3 sphere objects set up like the trees, with 3 Pyro simulations set up with clusters, and the default behavior, if we look in the tree source points, is to create our clusters as we saw before with the cluster node, and then to create a single point for each of the containers here, and then in the simulation we get a container for each of those single points. Now what's interesting, if we actually delete one of those points, if we delete some of those points, there we go, so we only have one, and we go back to the simulation, you'll see we only have one container. Now what's interesting, let me put that back to the 3 points. What's interesting about this instancing is this feature here, continuous. At the moment it's just reading these points in at the first frame and creating the equivalent containers for them. But what we can do is turn on continuous, which means it's going to read this every single frame. Now the danger of that, if it reads it every single frame, we're going to get a container for every single frame. So let me just demonstrate that. At the moment we have 3 containers. If I step forwards a frame, you'll see we get another 3, and I step forwards again, we get another 3. Because of this continuous, every single frame or time step now, we're adding another 3 containers, another 3 containers. So you're probably thinking that's completely useless. Well, no, actually, this is very useful. It means that this is constantly monitoring what's going on, and then we can choose when containers appear at which frame by making their equivalent points appear at the right time in SOPs. Let me just demonstrate this. So if I go back to the source points here, you'll see I've created a little branch of the network. Now what this does, it makes sure one point turns on at a frame. So on frame 1 I just have this first point. If I step forwards a few frames to frame 5, you'll see the next point appears. And if I step forwards to frame 10, you'll see the last point appears, but only for one frame only. Because remember, every frame they appear, they'll be creating a new fresh container. So since they only appear for one frame each, and there's 3 of them, we should only end up with 3 containers. One on frame 1, now one on frame 5, and then one appearing on frame 10. So let's see if that works. So make sure continuous is turned on. So there's our container on frame 1. If I step forward to frame 5, the next container appears because its point appeared. And then if I go to frame 10, the last one appears. And if I keep playing the sim, you'll see no more appear because we haven't got any more points at the end of this path appearing and disappearing. So continuous is very useful for building up your simulations through time. And this is how we're going to make our trees much more efficient. We're going to use this method so that our trees only appear, or the containers only appear, when the tree is burning. And when it's not, none of the trees will be simulating at all. So let's pop back into Houdini, into the other scene here. So how are we going to set this up? How are we going to make sure that only one tree appears at a time? But again, I'm going to attribute transfer in from my agent to help this. Oh, let's go to the tree source points. Excellent. So here are the source points that I want to mess around with. If I turn that on, let me turn off the ghosting. We'll see that we have these points, and our agent comes close to them. So again, I want to do an attribute transfer trick going on. But the trick is how to keep them on for a single frame. So the way I'm going to do that is I want to know what frame that they're going to transfer their attributes from my agent. Now I already have brought the agent in over here. In fact, let me drag this network over this side. We don't need that one. Let's lift these up, guys, up a little bit. Using shift and selecting a node will move it and all the ones above it. Let's just bring that a bit closer here. There's my agent and there's my points. So let's go back to our agent here. So what I want to do is I want to transfer another attribute in onto him. So what I want to do is know which frame, I want to know which frame he transfers his attributes onto these guys. So by doing that, I'm going to give them a frame attribute. So let's create a wrangle node, point wrangle. And I'm going to give them a frame attribute. We'll call it on frame. So we'll say f at on frame equals, and I'll say -1. So it's obvious that they've not got an attribute yet. I'm just going to make a copy of the visualize here. So we'll use another visualizer to see this value. And let's scroll down a bit. And instead of using color, let's use a marker. That means we'll get numbers. And the attribute here is frame on. Let's turn that on, frame on. Oh, I called it on frame, didn't I? So on frame, there you go. So let's call it on frame. It's handy if you get the right names. There we go. Now we see a value on those points -1. Now they're a bit high up for an attribute transfer to work. So let me just transform those down a little bit. So they're more sort of waist height-ish for our little guy here. Good. So they've got a -1 attribute. I'm also going to give our agent, let's make another wrangle. I'll make a copy of that wrangle. So again, by holding down Alt left dragging on this point wrangle, we'll make a copy. Let's plug that in. And on the agent himself, let's have this on frame as the current frame. So the agent himself is now displaying the current frame. Let's visualize that. So as we step forwards, we'll see it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the idea is that when we are transferring an attribute, we're going to transfer this frame attribute. So let's do that. Attribute transfer. So we're going to transfer onto our points from our agent. There we go, we cross the beams like they told you never to do in Ghostbusters. And let's put the visualizer on our points there. And you can see at the moment he's transferring frame 1 to them all, and as he moves they're counting the frame number that they're transferring. I want to give it a similar value to the other attribute transfer here, which is about 1.24. Let's just put that in 1.2 or something. Oh, it's 1.24, 1.25. Might need slightly higher values because with slightly different geometry there. I'm just going to slowly increase this using the ladder until I see that first point going up to frame 1. Oh, there you go, it jumped to frame 1. There you go, about 0.18. This is on frame 1, but this is still on -1. Now if I step forwards a couple of frames, you'll see this now switches to frame 8. So the point is, I can tell what frame they're actually turning on by, because it's when they change from -1 to a number. And I'm going to use that as the basis to get these to turn on and off for one frame only. So basically what I'm going to do is I'm going to work out for a particular point all the frames in the whole timeline. And if we look at all the frames in the whole timeline, well, let's do that actually. How can we evaluate all the points in the whole timeline, all 150 frames for a particular point in SOPs? Well, it's quite easy really. First of all, we could use a trail SOP. So if I add a trail SOP, naturally the trail SOP creates a trail. If I just step forwards a few frames, in fact we won't see it on a static object. Let's just do this on the agent for now. If I create a trail SOP on the agent and step forward, you'll see it creates a double geometry, and that's this trail length. If I create more lengths, we'll get so many for each frame here, or for each increment. So there's a trail of 5 of our agent. Now because these points, the static points aren't moving, we won't see all those trails, but I still want to trail it. In fact, we have 150 frames, so I want to trail it 150 times. Now if we do that, you'll see that we now have 600 points. If I look in the spreadsheet, we have a lot of points here, and I want to filter out, was it this on frame attribute? So only attributes here. Let's just type on star, which is all attributes beginning with on, and we'll see that we've got a whole bunch of points in the list here, which is good. So that's basically storing all the points together at once. We're seeing them all together in each of these guys. Now the other thing I want to do is actually, if you think about it, we've got 600 points here, and some of those points have got -1, some of them have got the frame that they're turned on at, etc, etc. Let me yep, got there, cool. If we visualize it, it'll be a bit of a mess. We see all the numbers at once over top of each other. Now I'm going to use a time shift node, because if I go to the end frame, then we'll see all those numbers changing. We go to frame 150, look, you can see we've totted up all those totals. If I look in the spreadsheet now, you'll see we've got all those numbers. But if I go back to frame 1, it's only really going to evaluate the first frame here. What I need to do is see the end frame all the time for this to work. So I'm going to use a time shift. So with the time shift node, I'm going to delete the channel, and I'm going to put in frame 150. So this time shift is always displaying at frame 150 now, even though doesn't matter which frame I'm on. And you can see we are displaying all the 600 points here. If I turn the visualizer on, you'll see the whole bunch of numbers. So that's a bit of a mess. We've got several 100 points here with a whole range of numbers, but I know that somewhere in here the numbers I want, because if you remember, it's -1 until the frame that he's transferring the attribute, and then he's transferring the current frame on there. So what I want to do is loop through each one of these individually. Now if you remember, they came from a cluster, so they still have their cluster attribute, so we can loop through the cluster attribute for that. So for that I'm going to use the for each point loop here. Let's select the bottom one, and I'm going to turn on attribute here, and let's set this attribute to cluster. Now to check that's working, I'm going to select the bottom node here and turn on a single pass. And that way I can see just one of these clusters, and there's the first one. If I cycle through, we can see we're treating each cluster individually now. So that's good. Now we just have a bunch of points from one cluster. There's our first one. That's the one we're sort of most interested in, because that's the one that the agent is transferring to first. So I click in the geometry spreadsheet now. We'll see that it is -1 on several of these points, and then all of a sudden we get our numbers counting, and we can see that the lowest number in fact is the first frame that we transfer the attributes from. But if I link through to say point 1 here, the other point, we can see again that at -1 where he's not transferring the attributes, and as soon as he starts transferring the attribute, we get a frame number, and the lowest frame number actually is the first frame that they transfer the attributes. So what I really want to do is have a look through this list and find the lowest number every time. Look, if I look at the next pass, again the lowest number is 89. Oh, hang on, I didn't filter them. So in that one it's 89. On the next point, the lowest number, is that also 89? He's also transferring there. So on this point, the lowest number is 48. And on the first point, the lowest number was, where is it? 80. And on this one, the lowest number was 1. So we can see that they're all different, but what I need to do is somehow work out the lowest number. Let's go back into the spreadsheet for this. So there's a nice little trick in Houdini that we can do that. Oh, it's this loop. So what we can do is, first of all, we can promote this attribute. If I promote this on-frame attribute up to detail attribute, we're using an attribute promote node. So let's drop in an attribute promote. The detail attributes only get evaluated once. So we can sort of do some nice sort of filtering here. Now the attribute I want to choose is my on-frame attribute, and I want to promote it from a point attribute to a detail. Now because there's only one value, it wants to know what to do with all of these values when we put it onto the detail. So we can either, well, let's click on the detail tab up here, and we can see it here. So at the moment we're taking an average of all those numbers, or we could find the maximum, or in this case the minimum. That's the one we're interested in, the minimum. But oh, there's a slight problem. The minimum is -1. Okay, that's right. Let me turn this off, because if you remember, all our points were -1 until they got turned on. So in order to make sure that the frame number is the lowest point, let's delete all the -1s first. We don't need those. So I'm just going to create a delete node. Let's put that in straight up here, and we'll set this to points, change this to expression, and say at on frame is equal to -1. So that's going to delete all the ones with -1 in. If we look at our list now, we just have the frame numbers. If I now attribute promote this to look at the minimum and look at the detail, you'll see the minimum here is frame 1. If I switch to another pass and have a look at the detail attribute, you'll see it's 88. That one's frame 8, and that was frame 48. So we have our unique numbers there. So what I want to do is actually want them on the point attributes. So let's promote that back. So let's just make a copy of the attribute promote. So I'm going to set this from detail back to point. It doesn't matter minimum, maximum, average, because there was only one value. So again, if I just do on star, there we go. We see we've promoted this guy back up to the points, and there's a whole bunch of points with that attribute on. Again, if I filter through the list, we'll see the different start numbers. So that's okay, except I only want 1 point. Otherwise, at the moment, I'll end up with 88 containers appearing. So we only really want to delete, keep one of the points. So let's add another delete SOP. I'm going to set this to points. I'm going to set this to expression, and we're going to say at pt_num is not equal to 0. So what that means is every point except for point 0 will be kept. So look, we just have the 1 point now, and it's got its one on-frame attribute. That's good. Where's my on-frame visualizer? Let's bring that down so we can see what we're getting here. There we go. So on frame 1 he's there, but if I keep going, he's still there. I only want him to appear on frame 1. So what I want to do is actually delete him. Now, if you remember, I only want him here. He knows what frame he should be on. That is this frame on attribute. So I'm going to use another delete SOP. Oh, what's going on there? So I'm going to add another delete SOP to make sure he only appears on frame 1. So again, set this to points, set this to expression, and we're going to say when at on frame is not equal. Oh, my caps have gone funny there. So at on frame is not equal to at frame. So what this means is when the not frame is not equal to the frame, so when this number, the on frame, doesn't match the current frame number, then he's going to be deleted. So as soon as I'm not on frame 1, he's not there. On this loop, let me turn off the single pass so we can see the other frames. Now if we remembered, if we look on the spreadsheet, we're only seeing one frame at a time. That's right, because we're delete. Let me turn off the delete. You'll see they're going to turn on frames 1, 8, 80 and 48. Let's turn that back on the delete. So frame 1, frame 8, there he goes, he appears on frame 8, frame 48, oh, where is it? There it is, 48, and then 88 later on. So there we go, we only have our points appearing for one frame and one frame only. So we won't get all those containers appearing constantly and just when he's transferring his attribute. Now there's the null that was linked into the sim. Let me just shake that out of the network. Let's come down here and let me plug that in. So that's now passing, this out instance points node is now passing those points to the simulation. Let's go into the simulation. And you'll see it's the out instance points. We'll turn on continuous this time, so it's going to load them in frame by frame. And you'll see if I just turn on the ghosting, we only have the one container here. Oh look, we need to offset that because our position stuff isn't working again. Let me just pin this using the pin icon at the top here. We'll go back to that, the tree points network. Where's it? Tree source points. There we go. So again, we could add a well, first of all, let's add a wrangle to adjust the size of these. If you remember, we had an expression here, so that was v at scale equals chv scale, like that, and then we could click on the little icon here to create the actual channel itself, and we could put in a value. So this is probably double the size now, so that'd be 5.3, 5.3 and 6. Oh, that's too much, isn't it? How about 4 by 4? 6 is probably alright. Yep, let's transform like we did before. Let's transform that up. Let's look in the side view, space 3. Transform that up a bit. Something like that. So the tree could get nice and high in the flames. If you look in the top view, space 2, that width, does that look alright? Could we maybe go a bit smaller? Try 3.5, 3.5, something like that will do. There we go. So we've resized the container in there. Let me pop back into the dot network and turn off the pin. That looks a bit better to start with. So let's press play and see. There we go. As he comes in, he sets fire to that tree. And look, on frame 8, we have some fire on that tree, and his box appears just for frame 8. We're only getting the one box. So that tree is now burning. And as we flip through, where's my agent? Let me look in the top view here. So as he gets towards frame 48, he'll get close enough to this tree to ignite it. There we go. So as soon as he starts transferring his attribute, the heat goes in there. The point appears on frame 48. Since there's already a sim happening, the container is able to resize around that. We're not using the fuel, otherwise it would resize around the whole tree constantly. And that's the kind of the effect I was after. He's spreading it onto that tree, onto those trees. So what I might do is just quickly flipbook this. Let's choose, let me change the camera's position so it didn't look that great. Where is he here? There he is. Let's have him walk around the trees sort of at this angle. There we go. So I'm just going to drop the resolution of this 0.07, 0.4 and maybe even slower, 0.3, and what I'll do is I'll just again flipbook this and pause the video while that happens. Now the flipbook has occurred, we can see our agent walking through and setting fire to all the trees. I'm quite liking that now. They seem like they set fire a bit too quick and bit fast, so I'm going to slow down some of that burning. I'm going to go to the combustion tab, and let's take the burn rate down so the fuel doesn't burn so fast. Let's bring up the fuel inefficiency so some gets left behind. It's not going to burn so hot and quick now. Let's bring up the temperature a bit and leave the gas where that is. Let's see how that looks. So this would mean it still get hot, because the reason I've turned it down is because he's going to be transferring heat in on every frame, and that's just going to be staying hot. So I've just brought down sort of the speed of which the fuel's burning, so the trees aren't just going to inflame quickly, they're going to burn a bit slower as he walks towards them. There we go, you can see that effect happening. Let me just flipbook that quickly. So particularly evident on this tree here. So I'll just pause the video while the flipbook happens. There we go, the flipbook's still happening, but if I press play we can see that the flames don't burst onto the tree so much. It's sort of more leisurely spread across the tree there. I might turn down no, to leave the disturbance actually. What I'm going to do now is increase the resolution and cache this out, and then we'll talk about rendering it. So I'm just going to go to the Pyro solver here, drop this to something like 0.015. Let's pop into the Pyro import tree here, and again we'll set this off to where the cache is, so tree cache. There we go. Again, I'm going to turn on compute min max values, and again I'm going to turn off the two rest fields because we don't really need those. We don't really want to see the fuel or the color, but we want density, velocity, temperature and heat. So again, let me just go back to frame 1, and I'm going to hit save to disk. So I'll be back when this is cached out so we can talk about rendering. The cache is completed, so I'm just going to click on load from disk and display the Pyro import fields completely, and we'll add another volume visualization node just to see what we're dealing with here, because we're ready to render. So let's do a volume viz. So this will just allow me to sort of get a rough idea of sort of the numbers we want in the shading. So again, density for density. In the emission we put in the heat. Let's put this up to about 10 for now. Coloring based on temperature using black body. Let's jump forward several frames to see that cache working. So there we go, we load that up, so it's looking very hot. So our temperature, let's remap that to maybe, let's find out the range of this, 3, 4, something like that, 4, 5, somewhere around there. About 5, and the heat, probably between 1 and 2 normally. See where that lives, up to something like that. Okay, so that's kind of interesting. We can add also a volume slice node to also get an idea of sort of the values we're dealing with here. So in the volume slice I can choose the heat field, for example. Let's just copy that name, put that into an attribute called heat. There we go. So if we go to geometry spreadsheet, let's get rid of this filter. There we go, so we can see our heat value for all the trees here, and we can filter this. We see it's up to about 2.2. Also, if you remember, we turned on out here compute min and max. So if we look in the details pane, in the primitives pane, we'll see the values for those here. So again, look, the max temperature, we're sort of peaking up here in the heat, is about 3. This can often be a lot higher because we're sampling a lot more points. Well, we're sampling every point with this min-max method, whereas the slice or scattering points, we're not necessarily sampling all the points in there. But it gives you an idea, a rough idea of where to start with your shader. That's the important thing. So for this guy, we're talking about 5 and 2. And for the agent, let's go to the agent import. There he is, Pyro import agent. So if we're looking at this guy, wait for it to load the cache in. We want to see what ranges, because we're going to be shading these differently. So again, this is between 2 and 2.5. So so they're both about 2 for the heat, whereas the trees are about 5 and this is about 2. So again, another reason for simulating them separately is that we can shade them separately too. So let me put the visualizer back on so we can see that. So to split up your render and display flags, actually you can hold Control and left click on the noggin here, and this just separates the render flag from the display flag. So you don't really need to do this for the visualizations, but it just would help a bit. So in the material palette, we'll rename this guy, this shader here to it's like letting me select. Let me go to the out here, make sure nothing's selected. There we go. So we'll call this Flames Agent, and then we'll just make a copy of these guys. We'll duplicate that, call this Flames Trees. So as a starting, well, we had these shaders set up, we thought quite nice for the trees to begin with. So my trees range now is about 5, although I'm going to adjust this. Sorry, the heat was about 2 and the temperature was about 5, and on the agent that was about 2, and that was about 2 as well. We'll start off with about 2 and maybe 3 for the agent. We'll see where we go for those. Let's make sure they have the right shader. So this Pyro import trees, make sure this has the tree shader on, and then the agent one, make sure that has the agent solver on. Excellent. So that all seems to be set up correctly for the shader. Let's look through the camera. So I'm just going to position the camera around a bit so we can see him wander through the trees. Maybe a higher view, something like this. Excellent. And then I'm going to go to my mantra node. Just make sure that the samples are right down. So 2 by 2. Let's turn off all the samples and ray bounces. For the minute, I'm just making sure the shader works, and I need to turn all this stuff on if I want all the interactive and bounce lighting, which we'll do at the end. There's no point making it go slow for testing. The other thing I'm going to do is just override camera resolution here. So let's turn off the update, the constant refreshing update. I just want to render this quickly to make sure my shaders are within the right ranges. So I'll just pause the video while the render kicks off. So now the render's kicked off. We're quite far away. The shaders and the colours look about right for the scale that we're dealing with. If I increase the samples a little bit, that'll look a little bit smoother. But I'm kind of pleased with that for now. What I'm going to do is actually turn on the interactive rendering. Do I need to adjust this slightly? No, I'm seeing detail. I'm seeing through the particular elements there of fire. Seeing all the detail like we've seen before. Let me just jump forwards back a few frames and render near another frame just to see. If I just increase the samples here, it'll just be a little smoother. So that render looks a little bit smoother. So what I want to do now is turn on the environment, and also use the volume light again, so we don't have those sampling worries that we had before. So let's just pop up to the geometry level here. I'm going to turn on the grid object, so you have a little ground plane in there. And what I want to do is use the volume light again, so we don't have to use the samples from the indirect lighting, and that'll give us a much faster render, much smoother looking render as well. So to do that, we can use the shelf tool up here again. So I'm going to click on the lights and cameras tab, and I'm going to click on volume light, but again left clicking to make sure nothing is selected in the viewport, otherwise it'll apply the volume light to that. And I'm going to click on the volume light. It says choose the volume you want. So we'll start with the trees. I'll select the tree volumes and hit enter. So this is going to create a volume light for us for the trees, and this does a couple of things. Let me just open this up and just drop this into the netbox. Call this volume light trees. So first of all, if you look at the Pyro import node here into the shading tab at the bottom, it turns off emission illuminates objects. So basically this volume is not creating indirect lighting. That's because our volume light's going to fake it for us. If we look in the volume light, actually in the area light options, you'll see it's picking up the shader for our volume and also the volume itself, and it's using it to illuminate the scene. We can increase the brightness with the exposure here. And also, if you want slightly better fidelity, you can increase the point samples and also increase the shading quality, which increases the density of points that it's sampling for the light there. But it's you get quite a good result keeping it quite low. So let me also hit escape and make sure nothing is selected. And I'm going to create a volume light for my little dude down here. So let me try and get a better view of him so I'll be able to select his volume more easily. There we go. So again, make sure nothing's selected. Choose volume light. Let me see if I can select him. There we go. Hit enter. So we've made a little volume light for the agent there. Drop that into his net box. Call this volume light agent. And just check it's picking up the agent shader and the agent volume, which it is. And that all seems good to go. So that's easy enough to set up. Let's have a look through the camera. And we'll try this camera angle first. So if I go over to the mantra node, there's a few settings I want to change here as well. I'm going to go to the limits tab and just make sure all the limits are set to 0, so we haven't got any indirect lighting from mantra, because again we're faking it with direct lighting from our volume light. And I'm going to click on the sampling tab here and just leave those settings for now. So I'm just going to hit render and see what happens here, and you'll see when we generate the point cloud, actually at the top of the render view, it will give us a little feedback as it generates the point cloud. There we go, generating point cloud. So there's this extra little step, but it speeds up the rendering. So there it's just temporarily saving out the point cloud, and now it's going to use that to render. And there it goes. So I'll just pause the video while that render starts. Now that render's complete, we can see with the volume light we get a nice smooth render with good quality indirect lighting, and we can see there's nice detail in the smoke and in the flames there. If I adjust the exposure down, we can see there is detail there for compositing later. So I'm quite happy with that. Let me just stop the render. So I think the next step is to find a nice camera angle and to render the sequence. So let me just lock the camera here and just find a slightly different angle. Maybe we'll have the lighting's a bit flashy. Let me just turn it off at the side there. So maybe we'll have the agent walk through from a nice sort of top angle here. Let's see how that looks at the beginning of the sequence. See how as he comes through, he'll start igniting the trees as he gets close to them, and they start bursting into flames. So I'm happy with this. The last thing I need to do really is turn off the override camera resolution, so we're rendering at a much higher res, and make sure that I'm rendering the image sequence. So I'm going to go and render the image sequence, and I'll catch you after that's done. Now that that has rendered, let's have a look at it. And we can see that our agent is on fire and he's walking through the trees. I can see the effect nicely of the flames spreading across the tree here, particularly this one in the foreground. The flames spread slowly across the branches. We can see the rendering is nice and smooth because of the volume light that we chose. The sampling's all nice and good, and it looks the interactive lighting's nice. We can see we've got good colours and some indirect lighting going on there, simulated by the volume light. And it rendered in a reasonable time because of that as well. I'm liking the turbulence and the speed that's going up the trees. I'm liking the density of the smoke there and the way that dissipates. So overall, I'm quite pleased with this effect. And we must remember that the using the clusters enabled us to scale this effect up and have multiple control over the multiple trees that are in the shot with various containers, each that we could control the resolution of them independently. One thing to note though is that the individual containers don't really affect each other, they don't interact with each other, but you'd have to do some kind of trick sharing velocity fields between them, but that's generally not really a problem with this kind of a method. The advantage is obviously that you can scale it up and have lots of different pyros occurring at the same time within one scene. So I'm pleased with that result. Hopefully you are too, and I do hope that you've enjoyed the video and got a lot out of it, and I look forward to seeing you in the next one. Thank you very much and goodbye.